So students, earlier I have discussed how the images are formed in plane mirror and spherical mirror, and this is the ray diagram for plane mirror, and these are ray diagrams for concave mirror. This is one type of spherical mirror. So I will explain this again. So this is the object, this is the plane mirror, okay, this is the object, and this is the image. So how the image is formed in a plane mirror? Initially, this is the incident ray falling on the mirror with an angle of incidence 0 degree. This is the reflected ray. Okay. This is another incident ray. This is the reflected ray. So these two reflected rays are not meeting at any point. This is going this direction, this is going this direction. So I extend them behind the mirror. So I am getting this point for this point of the object. Another incident ray from the bottom of the object. This is the incident ray. This is falling in the mirror with angle of incidence 0 degree. This is the reflected ray. This is the incident ray. This is the reflected ray. So extending the reflected ray, here I will get this point of image. Okay, so finally I will get the image here. This is the image and this is the object. So what are the characteristics of this image for plane mirror? It forms behind the mirror at the same distance from the mirror. The distance from the mirror to the object and distance from the mirror to the image is same. Size same. The size of the object and the size of the image are same. This is a virtual image because the reflected rays are, this is the reflected ray. The reflected rays are not meeting at any point. Here you can see this is the reflected ray, this is another reflected ray, but they are not meeting at any point. So they appear to meet at this point. This reflected ray and this is a reflected ray. So they appear to meet at this point, this point. So this is a virtual image and this is an erect image. This is an erect image. You can see the top, this is the top part of the object and the top part of the object remains at the top of in the case of image. Okay, so this is the erect image. So this is called erect image. This is erect image. And its opposite is inverted image. So this is erect image for plane mirror. Now let's see for spherical mirror, that is concave mirror. Here there are several cases. I'll discuss all the cases here. First case is where object is present at infinity. This is the object, it is present at infinity. So this is center of curvature, this is focal point. Okay, here this is an incident ray parallel with the principal axis. This is principal axis, this is incident ray. This incident ray falls on the mirror and reflect from the mirror. After reflection, this is the reflected ray. This reflected ray goes through the focal point. This is another incident ray, and after reflection it goes through the reflected ray goes through the focal point. These two reflected ray are meeting actually at the focal point. So what are the nature of this image? The image is formed at the focal if it is a very small image, so it is a highly diminished image. The image is real image, because actually the reflected rays are meeting at this point, and this is an inverted image. This is here, this was erect image, but here this is inverted image. This is inverted, this is inverted image. Okay, so case 1. Case 2, you can see this is the object. The object is present just beyond point C, that is center of curvature. This is center of curvature, this is object. Object is present just beyond center of curvature. So this is the incident ray parallel with the principal axis, and after reflection the reflected ray goes through the focal point. Okay, this is one ray. This is another ray. This ray comes through the focal point, goes through the focal point. This is focal point, and after reflection the reflected ray goes parallel with the principal axis. Here the incident ray is parallel with the principal axis. Here the reflected ray parallel with the incident axis. So here two type of incident rays are present. One ray is parallel with the principal axis, one incident ray is parallel with the principal axis, and another incident ray goes through the focal point. Here the reflected ray goes through the focal point, and here the reflected ray is parallel with the principal axis. So you should remember that here two types of rays are present, where here one type of incident ray is present, that is this is parallel with the principal axis, incident ray. Here this ray is parallel with the principal axis, this ray also parallel with the principal axis. Here this incident ray is parallel with the principal axis, this incident rays goes through the focal point. Okay, this reflected ray goes through the focal point, and this reflected ray is parallel with the principal axis. So image is formed between C and F, and you can see the size of the image is slightly smaller than the object. So what are the nature of this image? This image is formed between C and F, and it is diminished image, slightly more smaller than the object. This is a real image because actually the reflected rays are meeting at point. Okay, and this is an inverted image. You can see this is an inverted image. So there two types of incident rays are present. Here, now case 3. Here this is the object. You can see this is the object, and this is the image. Now this is the object and this is the image. So this is initially this is an incident ray parallel with the principal axis, and after reflection the reflected ray goes through the focal point. Okay, this is the direction, and another incident ray that goes through the focal point, and after reflection the reflected ray becomes parallel with the principal axis, because these two reflected ray, this ray and this ray, are meeting at this point. So this is an image, this is an object. So what is the characteristics of this case 3? You can see the object is present at C, that is center of curvature. So image is also present at C. Okay, and the size of the image is same with that of the object. This is the object, this is the image. So size of the image is also same as that of the object. Okay, this is the real image because the reflected rays are meeting at this point. Okay, and this is an inverted image. So here and here two types of incident rays are present. One is parallel with the principal axis, another incident ray goes through the focal point. Okay, here and here you can see, but here only incident ray that are parallel with the principal axis are present. Okay, here this ray is parallel with the principal axis, this ray goes through the focal point, and here this ray parallel with the principal axis and this ray goes through the focal point. Here this reflected ray goes through the focal point and reflected ray parallel with the principal axis. Here this reflected ray goes through the focal point and this reflected ray is parallel with the principal axis. Now in case 4, where the object is present between C and F, here you can say in this incident ray, this is parallel with the principal axis. Okay, this is reflected ray, goes through the focal point, and another incident ray, that is goes through the focal point, and after reflection the reflected ray becomes parallel with the principal axis. So these two reflected rays meet here, and this is the image. This is the image, this is the object. So you can see the image size is slightly greater than object size. Okay, here also two types of incident rays present. One is the incident ray is parallel with the principal axis, another incident rays goes through the focal point. So, and one reflected ray goes through the focal point, and another reflected ray is parallel with the principal axis. Okay, so here, so in case 2, case 3 and case 4, you can see two types of incident rays are present. And in case 5, so in case 4, you can see the object is present between C and F. So the image is formed beyond C. Image is found beyond C. Okay, it is enlarged image. Okay, this is a real image because reflected rays are actually meeting. One reflected ray goes through the focal point, another reflected ray that is parallel with the principal axis. Okay, these two reflected rays are meeting here. So this is a real image, and this is an inverted image. And in case 5, the object is present at focal point. So here, okay, so this is one incident ray that is parallel with the principal axis. This ray is parallel with the principal axis. This is incident ray. Okay, after reflection, the reflected ray goes through the focal point. This is a reflected ray, this is a incident ray, this is a reflected ray. Okay, this ray goes through the focal point. This is a incident ray parallel with the principal axis, this reflected ray goes through the focal point. So here another type of ray is introduced. You can see from this point a ray falls on the mirror with the angle of incidence of 0 degree. You can see, suppose a ray, this ray goes here, this is the incident ray. Okay, this is the incident ray and falls on the mirror with this angle of incidence 0 degree. So it will just, the reflected ray will be in the opposite direction. Okay, opposite direction. This is the reflected ray. You can see if this is an incidence ray falls in the mirror with 0 degree, suppose the angle of incidence is 0, so the reflected ray will be follow the same path but in opposite direction, because angle of reflection also will be 0. Here the angle of incidence is if 0, the angle of reflection also will be 0. Okay, so it will follow the same path, the reflected ray will follow the same path but in opposite direction. So here it will follow the same path in opposite direction. Now the reflected ray will go through the center of curvature. You can see in a circle, suppose this is a circle. Okay, this is a circle, this is a center, and this is a tangent. Okay, so from any point we can draw a tangent. Now from that tangent point that touches the circle, if I draw a line, this angle is 90 degrees. So here you can imagine that the angle of incidence will be 0 degree. Okay, and the angle of reflection will be also 0 degree. Here the angle between the incident ray and mirror is 90 degree. Okay, angle of between the mirror and the incident ray. Okay, this is the mirror, this is the center, so this is incident ray, this is reflected ray. So this angle, this is a mirror, so this angle is 90 degree. The angle of angle between the incident ray and the mirror is 90 degree. So the angle of incidence is 0 degree. Okay, have you understand? If this is a mirror, this is the incident ray. Okay, this is the angle between mirror and incident ray. This is the angle between mirror and reflected ray. So if this incidence ray becomes like that, so these become reflected ray. So here the angle between the incident ray and mirror is 90 degree. So the angle of incidence is 0 degree and angle of reflection will be also 0 degree, as the angle between the incident ray and mirror is 90 degree and the angle between the reflected ray and mirror is also 90 degree. So here this is 90 degree angle of incidence, and angle of mirror is angle of incidence and angle of reflection will be 0 degree. So the reflected ray will go through the center of the sphere, that is center of curvature. Okay, if this is 90 degree, you can say that if this is 90 degree, this is a, suppose this is a tangent, this is a tangent. So this, from this tangent point, the reflected ray will go through the center of the sphere, that is center of curvature. So here this is angle of incidence 0 degree, angle of reflection 0 degree, and the reflected ray will go through the center of curvature. Here this is another reflected ray, they will never meet in this direction or in the back of the mirror. So here the image will form at infinity. Okay, image will form at infinity, and it is a highly enlarged image. It is a highly enlarged image, and this is a real image. Okay, image will form at infinity, and this is a real image form at infinity, and this is an inverted image. This is the characteristic of case 5. And case 6, here the object is present at within F, that is, this is F, point F within F. This is the object. Okay, this is the object. So initially one incident ray goes through with the parallel of principal axis, and after reflection the reflected ray goes through the point F. Okay, similarly one incident ray falls on the mirror with angle of incidence 0 degree. So the reflected ray, that is the angle of reflection, will be also 0 degree. So the reflected ray will follow the same path but opposite direction. Similarly like that. Okay, so this is reflected ray, and this, it will go through the center of curvature. So these two ray will not meet in this direction, never. Okay, if I extend this reflected ray, so I have to extend them behind the mirror. Behind the mirror, they are meeting at this point. So this is a image, this is the object, this is the image. So you can see where the image is formed. Image is formed behind the mirror, and it is an enlarged image. It is an enlarged image, and this is a virtual image, because actually the reflected rays are not meeting at the front of the image. So I have to extend the reflected ray in the back of the mirror. So this is the virtual image, and it is an erect image. This is the top part of the image, this is the top part of the object, this is the top part of the image. So this is an erect image. Okay, so I will discuss So these are all 6 cases. So I'll discuss about convex mirror in my next class.